relays we have, over, current, differential, directional and distance production relays we have, and circuit breakers. What are the types of circuit breakers involved in power system? And system stability concepts. So the stability we have to estimate with the help of equal area criterion. So these are all the detailed syllabuses which you have in your power system. So power system, these topics are included. I hope the syllabus is clear to everyone. If it is possible, make a note of the syllabus. Let me solve some numerical examples. So starting from your basis, we have some numerical examples. I try to solve some numerical example based on your process. First one is fundamentals of power system. So I will explain the question with the answers and fundamentals of power system. We have 80 to 90 questions we have. Detailed solutions also I have. So nothing to worry for the solution question also. Forty-one questions now. In fundamentals of power system, we have 41 questions. So first question is, first I will share this screen. Yes. So in the fundamentals of power system, I need to solve first question. A 20 kV transmission line has a series impedance of 4 plus J60 ohm. That is the impedance, that is 4 plus J60 ohm. A shunt admittance of J0.5 S. So the unit MVA, that is shunt admittance in terms of S is given, that is J0.5 S. And I choose 100 MVA and the line voltage as base values. The per unit impedance and per unit admittance of the lines respectively are. So the actual values is given. We need to find out what is the per unit value. So it is a transmission line. So what is the transmission line relation? That is impedance in terms of admittance. That is your actual value of the impedance. That is 4 plus J60 into your MVAB divided by KVB whole square. That is the formula we deal in your classroom solutions. Very only on the formula. So on the formula use we are going to solve. Right. So remember your KVB is 20. The Z is 4 plus J60 Y is J.5, MVAB is 100. These are all the informations we have. To find out what is your per unit impedance as well as per unit admittance. That's it. I'll open my paint screen. Paint screen is shared now. I hope the screen is visible to everyone. How that relation. First, we need to find out what is that per unit. That is impedance. The per unit equal to what's that actual. It is given in the problem. Into MVAB divided by AVB square. That actual is nothing but 4 plus J60. Correct. Multiplying with your MVAB is 100 MVA. 100 into 10 power 6. And the KVB is 20 into 10. If you are solving the values, the 40 plus J60 multiplying with the MVAB divided by KVB. So here 10 power 6, 10 power 6 get cancelled. 100 by 20 is 5. So 5 into 4 plus J60. So if you are solving your values in your scientific calculator, you may have value as 1 plus J15 per unit. 1 plus J15 per unit. So this is the first quantity here. This is column number 1. It's of our system, FOPS. The first part is that PUV and that part we determine. The next one is X per unit. That is, we have to find out your admittance. That's why we need to find out. The same only, I just replace that by Y. Rest of the things are same. MVAB, that is KVB remains same. The value only differ. In place of that, or second one, we need a Y per unit. is y actual. Y actual is given as j point. MBA will be the whole square. So the answer for this one is the answer solve பண்ணீங்கன்னா j 2.0 கிடைக்கும். 2.0. Okay. In this manner we have to. So here we have 4 options. So the option number B is relevant to the answers. It's 1 plus j15 comma j20. So that answer we have to pick up. சரியா ஃபர்ஸ்ட் क्वेश्चन புரியுதா நெக்ஸ்ட் நம்ம செகண்ட் क्वेश्चन போலாம் first question we solved z per unit and y per unit. Next one is second question. The per unit impedance of an alternator corresponding to base values 13.2 kV and 30 MVA is 0.2. The per unit value of the impedance for the base values 13.8 kV and 50 MV in per unit will be. So here the alternator corresponding base values is given. So my KVB is 13.2, MVAB is 30, and reactance value is 0.2. So we need to find out what is the Z per unit mu max. So the base values are indicated as 13.8 kV and 50 MVA. So this is so simple, which we are using in our classroom sessions. First unit How we can solve our second question. So this is the question. The per unit impedance of an alternator corresponding to base values. 13.2 is new value, 30 is new, 0.2 is old. So the base values, the kVb volt is 13.8 and MVAB volt is 50. Sorry, MVAB new is 50. So what is the relation we have? That per unit volt into MVAB volt by MVAB new into kVb new by kVb volt the whole square. So if you are solving, so the answer should be C, option C, that is 0.305. Right, solve. So that per unit new value needed. So the volt is 0.2 is given into MVAB volt is 50, that is the previous value, and 30 is the machine values. 50 is base value, 30 is machine's value, into kVb new. So kVb new given in the problem is 13.2 and volt is 13.8 the whole square. If you are solving, the answer is 0.305 per unit. So the answer is option number C. Option C is the right answer. Okay, third question. So the generator is rated as 500 NVA, 22 kV. It is star connected windings. Have a reactance of 1.1 per unit. The ohmic value of the reactance of the windings is. So in this case, we need to find out what is the ohmic value of the reactance. So X value we need to find out. So the MVA value is 500, kVb is 20. So the type of connection is, it is a star connected machine. Reactance, that is for the case of star connected windings, the reactance value is 1.1 per unit. So the values are given in per unit. So we need to find out what is the actual value. So we know that base impedance equal to kVb square by 500. I hope you people are aware of this relation. Is base impedance Z equal to kVb square. kVb is 22, MVAB is 500. That is 0.968 ohms. They are asking the reactance value in terms of ohms. So already we have X. That is X value is yes.
Screen is not visible, sir.
Screen not visible. Okay. இப்போமா தெரியுதுங்களா? ஸ்கிரீன் தெரியுதா?
No, sir. இப்ப தெரியுது சார்.
பெயின் ஸ்கிரீன் தெரியுதாமா?
தெரியல சார், போயிடுச்சு.
ஒரு நிமிஷம். Now visible amma?
நோ சார். இப்ப தெரியுது சார்.
Okay. So that value we determined as 22 square by 500. That is 0.968 more. So the actual value which is given is 1.1 already. So 1.1 per unit is given. I'm multiplying with z. This is the actual ohmic value of the reactance. 1.1 0.968. So it is 1.065 ohm. So hence B is the correct option. Yeah. For the third question. So third we solved, second also solved. Fourth one, how much amount of real and reactive powers drawn from a three-phase 440 volt line by a three-phase 15 HP motor operating at full load? So the efficiency is 90%, power factor is 80%, just lagging power factor. So we need to find out the real power as well as the reactive power. So we have to convert the HP into kW. So 1 HP equal to 746 watts. So my current is 15 into 746 whole divided by root 3 times of 440. That is the line voltage. And then efficiency is 90%, 0.9, multiplying with power factor 0.8. First, we need to find out what is the current. So once we determine the value for current, we can able to find out what is the real power drawn from the line and reactive power drawn from the line. So I move on to the paint screen. So very quite simpler questions also you may get in your GATE examinations. People think of it as they are asking only complicated questions. You may get the simple questions also in your GATE examinations. So first we need to find out your modulus of I now. The modulus of I equal to, I'm just converting my HP into watts. So 15 into 746. 1 kilowatt, 1 HP equal to 746. So 15 into 746. Whole divided by root 3 times. My line voltage is 440. Efficiency is 90%, so 0.9. And power factor is 80%, so 0.8 lagging. The current value should be 20.39 amps. So next one is we have to find out what is the real power drawn from the line. Simple relation we have. E equal to root 3 L I into your power factor plus cos pi is 0.8. So already we know that. So VL is 440. I we determined just now. So 20.39 into 0.8. So it is 12431 watts or 12.431 kilowatts. Vice versa, we have to find out the value for reactive power. In place of cos pi, we have sin phi. So how we can convert our cos pi into sin phi? So just to take the inverse value, that is your cos angle, cos 0.8 should be 36.86. Sine inverse of 36.86, the value should be 0.6. Reactive power Q equal to Q equal to 23 PL I sin phi. The sin phi is 0.6. So 0.6 வந்து நம்ம தான் கண்டுபிடிக்கணும். Root 3 into 440 into 20.39 into 0.6. So the answer is 9324 var. So the unit for reactive power is volt ampere reactives. In terms of kVAR means 9.324 kilovolt ampere reactors. So in this manner, we have to find out our real power as well as your reactive power. So simple one. So in gate examination, not only you may get the 1 mark or 2 mark question, you may get statement questions also. So the minimum range is 2, maximum you will get 5, 10 also. So based on the same statement, you will get 10 different questions. So that is also possible in your gate exam. Not only in your gate examination, it is common to all public sector competitive examination, that is UPSC. So UPSC conducted IES, that is Indian Engineering Service. Like your IAS, for engineering we have IES, Indian Engineering Service. So for that exam also we may have questions like this. So whatever I am teaching, it is common to all competitive examination. It is relevant to your core sector. These questions are repeated n number of times. So the previous year repeated questions only I am. So next is a statement question. So 5th and 6th question is, it is a statement oriented question. A 16 kV, 200 MVA, 3-phase round rotor synchronous generator is operated on a infinite bus having a voltage of 15 kV. The generator has negligible losses. The synchronous reactance of 1.65 per unit. The internal EMF EG, the power angle del of the generators are found to be 24 kV. That is the internal EMF is 24 kV line to line, and the power angle del is 27.4 degrees respectively. So these are all the informations commonly given in the 2 questions. For the case of 5th question and 6th question, we have the common data. For the common data, we have 2 questions. So just remember the questions and the question values. You just remember 16 kV, 200 MVA, 3-phase round rotor. So these things you have to remember while solving the problem. And then your EG is given, and then your angle, power angle is also given. What is the value of line current? Line current வந்து எப்படி கண்டுபிடிக்கும்? we have the question. If the line current of the machine is reduced by 25% at the same power factor, the value of new internal EMF Eg is. So the line current is reduced by 25% means what is the new internal EMF? So the internal EMF Eg which is given as 24 or 24. If it is the current value is reduced by 25% means what is the new value of the internal EMF Eg? Correct? So we are choosing our base values as 16 kV and 200 MVA as base. To find out VA, 15 by 16, we have getting our per unit values, that is 0.9375. So your EG is, EG at an angle del is 24 by 16. 24 is given, 60. The angle which is given as 27.4. So EG at an angle del is 1.5 at an angle 27.4. So the generator voltage equation is nothing but Eg of del equal to V of angle 0 IAXT 90 minus theta. Yeah, so இந்த IA நீங்க அந்த trigonometric அந்த relations substitute பண்ணிட்டு உங்களுக்கு வந்து பாத்தீங்கன்னா 0.4818 angle minus 29.75 கிடைக்கும். So I which is equal to your base value, that is 200 into 10 power 3 whole divided by root 3 times of 16. So the base current is 7.217 kiloamperes. So we need the current values. So 0.4818, that is IA generated voltage, we have current 0.41. I am multiplying with your base current IB. If I am multiplying, I may get 3.477. So what is the right option? So option B is the correct, 3.477 kiloamps. The next question, if the current is reduced by 20%, so IA is nothing but not 100%, just 75%. So 0.75 into 0.4818. So you may get 0.3614. 90 minus theta is 60.27. Theta value. The same equation, Eg equal to VA angle 0 IAXT. So VA is 0.9375, IA is 0.3614, and the XT value is 1.65 at an angle 60.27. You are solving the equation, you may get 1.337 at an angle 22.8 per unit. So if the line current is reduced by 25%, the generated EMF value should be 1.337 at an angle 22.8 per unit. So D is the right option. So for the same statement, you have several questions. That is also a patterns. We may have 5 questions also. So seventh question, 8th questions are so simple only. So the power factor is given. Easier power factor. And then a resultant power factor of the system. So based on your circuit analysis, you can easily find out these values. Yeah. எல்லாமே வந்து நீங்க இந்த சர்க்யூட் அனாலிசிஸ் டிடில பார்த்து சர்க்யூட் அனாலிசிஸ் யூனிட் வந்து யா 3 phase பவர் ஃபேக்டர் அதை நீங்க படிச்சிருக்கீங்க. பாருங்க previous question வச்சு கூட அடுத்த question கேட்கலாம். It's not a statement, but based on the previous question also we will get the next question. That is also possible. இது நம்மளுடைய PD as well as PSL application. It is a feeder based problem. A radial transmission system with the ratings and reactances of the various components is shown in the following here. A load of 60 megawatt at 0.9 power factor lagging is fed from the 66 kV substation. It is to be maintained at 60 kV. The terminal voltage of the line of the synchronous machine MS. We need to find out what is the synchronous machine terminal voltage. Either it is 10.30 or 13.5 kV, option B 12 kV and option D 72 kV. So V1, V2 is your bus voltages. The first bus voltages we doesn't know, but second bus voltages it is 60 kV. இதுதான் கேட்டிருக்காங்க. V1 தான் கண்டுபிடிக்கணும். Second bus voltage is given, but the motor's terminal voltage is not given. So we need to find out what is V1. The transformer information is given. That is left hand side is with a step up transformer 11 bar 220 kV. The MVA is 100, reactance is 10%, and you have the transmission line reactance is J151. Again, the transmission line right hand side you have 220 bar 66 kV. This is step down transformer. It is connected to your 60 kV line. So the load is tapping 60 megawatt 0.9 power factor lagging. So our intention is we have to find out what is V1. The V1 of the non-contributing. The problem is what. So we can do it in top. Check on it. It is 11. So I am choosing 100 MVA base and I am representing all the quantities in per unit. So first of all, I need to find out what is the transformer reactance, which is given in the problem itself 0.1 per unit. And second transformer it is 0.08. And transmission line we have to find out actual value into MVAB divided by KVB square. It is 0.31. And load is 60 by 100. So for all the quantities, I just taking the base of 100. So it is 0.6 per unit megawatt. Power factor is 0.9. Voltage at terminal 2 is 60. So by 66, you may get 0.909 as your V2. And I2 is 0.6 divided by 1 into 0.9, angle minus 25. So if you are simplifying, you may get the current as 0.667. So the generator terminal voltage V1 is nothing but V2 plus J times of all the reactances of your transmission line, transformer 1, transformer 2, multiplying with your current. So all values will vary. Now it is V1 is easy, 1.09 an angle 15.6. So if you are converting the actual value with your base value, base is 11. 1.09 into 11 is nothing but 12. So hence your option is B is the right answer. Twelfth question உங்களுக்கு அதே pattern தான், angle கேட்டு. Yeah, 12th question நீங்க solve பண்ணலாம். 12th and 13th is statement question. I'll show the question. It is also a statement. So statementல வந்து ஒன்னு தப்பாயிடுச்சுனா ரெண்டாவதும் தப்பாயிடும். So in gate you have 1/3% or 1/3 portion is your negative. For every wrong answers, 1/3 mark is deducted. 2 mark means 2 into 1/3. 2 into 1/3. it is approximately 0.60 for 2 mark wrong answer means the actual correct answer is 0.6 mark is deducted. 1 mark means 0.33 deducted. The 12 and 13 is it is a statement question. 645 MVA 24 kV synchronous generator is feeding full load at 0.9 power factor lagging at the rated voltage. The generator has a synchronous reactance of 1.2. So the 12th question is what is power angle failure? And second one is based on the same statement, we have to estimate what is the reactive power drawn by the load. Yeah, the learning of the configuration. So your next is so the impedance diagram of the power system is shown in figure. The bus admittance matrix Y buses. So you have admittance for impedance diagram and you have 4 matrices. So we need to find out what is the correct value for the corresponding diagram. And Y bus frame. So it is a 4 bus system. First bus, second bus, third bus, fourth bus. We have 4 options. You solidna end option on this. Clear பண்ணி காமிப்பேன். ஈஸியா தான் இருக்கும் பட் ஃப்ரேம் பண்ணி. Either A, B, C or D. Which matrix is correct? அந்த PDF உங்களுக்கு அனுப்புறோம் குரூப்ல ஷேர் பண்றேன். கேட்டுக்கு சீரியஸா ப்ரிப்பேர் பண்றவங்க வந்து பாத்தீங்கன்னா யூ மேக் யூஸ் ஆஃப் த PDFs. Power system பொறுத்தவரையிலும் என் power not only power system all chapters I am having materials. So I am prescribing gate multiple choice questions with complete solutions. Noida and Company publishing. We have 3 volumes. So power system is comes under volume number 1. Author is R.K. Kamodia and Ashish Murolia. So more than 10 years I'm referring the 3 volumes for teaching students in place of theory portions. Just incorporating the gate questions also while I'm teaching. If you are listening my lecture sessions carefully, I just incorporating the gate questions also. When I'm teaching, so these topics or these portions or these problems comes under gate. Like that I may emphasize. So if you have doubt means you may check my lecture videos. You have 29 to 30 lecture videos available in my YouTube channel. It's possible means go through it. It is also useful for your gate examinations. So the one question is homework for you. You just solve it. Next class you may say the answer. Just take the snapshot and frame what is your 4x4 matrix. That is the right option. Okay, well, remaining things we may continue in the next session. Probably tomorrow I will post another sections or some faculty member from another topic they will conduct. Thank you, ma. Thank you for your cooperation. Thank you.